Standard SP5 starts the probability standards, and this one focuses on the likelihood of an event occurring. We're focused a little bit on probability, but a lot of this is saying how likely is something to happen. So we're going to start here with problem number 8. During the weather forecast, you can read the probability of a storm happening tomorrow. Match each term to the corresponding probability of a storm happening tomorrow. The first one says the probability of a storm is less than half. That means it could happen, but it's less than a 50% chance, so it's unlikely. We could say it's less than 50%. The next is the probability of a storm is greater than half. Well, that's more than a 50% chance. It doesn't say it will happen, but it does mean it's likely. The next is the probability of a storm equals 1. Well, 1 is equal to 100% chance. This means it will happen. This is certain. There will definitely be a storm. The last one is the probability of a storm is 0. 0 is the same as 0%. This means it can't happen. It is impossible. I want to add one note. Probability must be a number between 0 and 1. It can't be negative. It can't be greater than 1. It is always going to be between 0 and 1 when written in decimal form. Number 1, 30 volunteers will wear one of 7 blue, 5 green, 9 yellow, and 9 red aprons during an upcoming food drive. If the aprons are assigned randomly, what is the probability that a volunteer is assigned an apron that is not green? Okay, well, here's the ones that are not green. 7 blue, 9 yellow, 9 red. So 7 plus 9 plus 9 is 25. And the total of aprons was 7 plus 9 plus 9 plus the 5 green, which were 30. So it's a 25 out of 30 probability. Answer choice D. And of course that could have been reduced to 5 out of 6 by reducing the fraction, but it didn't reduce it, and sometimes it doesn't. Let's look at number 4. Miguel's comparing the probabilities of 2 spinners. Select all the true statements that Miguel made. So notice spinner A has these random numbers 1, 2, 1, 2, 1, 4, 3, 3. Spinner B is 1, 2, 3, 4. So spinner A is twice as likely to land on 1 as spinner B is. Well, let's see where all the 1s are. Spinner B is 1 out of 4 chance. Spinner A, 1, 2, 3 out of 8. So 3/8, is that equal to 2 times 1/4? No, it's not. The probability that spinner B lands on an odd number is 1/2. Well, we have 1 and 3. That is 2 out of the 4 sections that are equal size sections, and that does reduce to 1/2, so that is true. The next one is the probability that spinner A lands on 2 is 1 out of 4. Well, we have 1, 2 out of 8. So there's 2 out of 8, which does reduce to 1/4, so that is true. The next is spinner A is not a fair spinner. Well, without even going further and looking at the other numbers on spinner A, we see that 1 occurred in 3 sections and 2 occurred in 2 sections, and you could actually further see that 4 occurred in only 1 section. So that is correct. It is not a fair spinner. It's not got an equal number of sections per number. And the last one, spinner A and B are equally likely to land on an odd number. Well, we already said that spinner B can land on an odd number half of the time. So let's look at spinner A. The odd numbers are 1, which occurs 3 times, and 3, which occurs 2 times. So that's 5 out of the 8 times, which is not equal to the half of the time that spinner B would. So that is a false statement. Number 5, Holly throws a 12-sided numbered solid with faces labeled 1 through 12. So this is like a 12-sided dice. What is the probability that Holly will roll a number less than 1 Well, how many of those sides are less than 1? None of them. So what is that probability? 0. Or you could write it as 0%. Standard SP6 is about theoretical and experimental probability. Theoretical is what you would expect to happen every time. Experimental is actually running an experiment and seeing what has happened to use that to predict what you would expect to happen next. So number 1, Mason plays a game by flipping 3 fair coins. He wins the game if all 3 coins land facing heads up. If Mason plays 400 times, how many times should he expect to win? Well, first of all, let's just see the probability of landing heads up 3 times. So, heads up 3 times. So that would be 1/2 times 1/2 times 1/2, which is 1/8. Okay, so now let's use this then to make a prediction. We're going to take our probability and use it to make a prediction. So our probability was that it would happen 1 out of 8 times. So out of 400 times, what would you expect to happen? So we'll cross multiply. 8 times x is 8x. 1 times 400 is 400. Divide both sides by 8 to get x by itself. And we find that x is 50. So you would expect him to get 3 heads in a row 50 times, or 50 flips out of 400. Number 3, how does the theoretical probability of the event roll a 1 change when a standard 1 through 6 number cube is rolled more times in an experiment? Well, we're asking how the theoretical probability changes. It doesn't. Theoretical probability does not change. An experimental probability could, but not theoretical. Number 4, Sasha uses a spinner with 6 equal sections, number 2, 3, 4, 5, 6, and 6 to play a game. Sasha spins the pointer 120 times and records the results. The pointer lands 15 times on section number 2, 19 times on 3, 25 times on 4, 29 times on 5, and 32 times on 6. A winning spin is a 6. Find the theoretical and the experimental probability of winning and then compare the two. Okay, theoretical probability. This is what is expected. What do you expect to happen? Okay, so how many times would it land on the number 6? Well, there are 2 6s out of 6 numbers, which is 1/3 of the time. Or you could look at that as about 33%. Then the experimental probability is taking how many times it lands on a 6, 32 times, out of the 120 times that the experiment is run. And that reduces to 4 out of 15, or we could compare it as a percent. It is about 27%. And so, and this is actually based on results. This is based on the experiment. So which one's greater? The theoretical probability is greater. The number was greater. It was 33% chance as opposed to a 27% chance.